Welcome to this episode of Inside Evo. Now, very recently Evo visited the Koenigsegg factory in Sweden and got a world exclusive first drive on the 1.1. You can find out more about that car just here. Now, while we were at the factory, we got an interview with Christian von Koenigsegg and we had a really good look around this amazing place. There is a review coming up, a video review coming up on the 1.1, but in the meantime, we thought you'd like to watch this interview with the boss himself, Christian von Koenigsegg. So enjoy. 17 minutes long or so, so it's a little bit long, but we think you'll enjoy it.
So the motivation to create the 1-to-1, even though we already had a superbly fast car that also was good for track use, was that some of our customers really wanted more of a cup car, a GT car, just specifically developed for the track, but they also came with the demand that you should have full road usability and full homologation. And that was a bit of a challenge, because what we ended up building was more or less a car that looks and feels like a GT1 car on the track, but then you push a button, it races up and you have all the creature comforts, air conditioning, satellite navigation, Bluetooth telephone, air conditioning, whatever that our normal cars have. But we had to save weight, and we had to have more downforce, we had to have a stiffer chassis setting when needed on the track, and also lighter weight. So yeah, that was the motivation, and that was the challenge. So the good thing when we decided to focus is what was going to be a track or a cup car almost, we could have a much stiffer chassis setting and stiffer springs. And we managed to get that adapted with the ride height setting so that it stiffens up when it lowers down, and that enabled us to, allowed us to have much higher downforce number than we otherwise could have. So we actually went about and bought a supercomputer 1.5 years ago. We've done over 2,000 hours of CFD iterations on that supercomputer, and we also even extended that work onto the cloud on the internet to have access to even more supercomputers. So we just kept on running iterations, flowing the car internally, underneath and over the body to find the best and safest balance of downforce, low drag, and a system that worked at different ride heights and also adaptive elements. But it was really an iterative process of thousands of hours of fine-tuning. The car, of course, looks quite similar to an Agera, but if you look closer, there are just many details everywhere and adaptive functions everywhere to make it possible to go from a downforce number of around 200 kilos at 280 kilometers per hour to 600 kilos at 280 kilometers per hour. So that's how adaptive it is. So we have adaptive aero devices spread out over the car from the front to the rear. If we start at the front, underneath the front splitter we have two hidden flaps, individual functioning flaps, so they can move individually. So basically in the startup setting it's high downforce, so it's like two Venturi tunnels aiming upwards towards the front wheels, and the faster we go and the more we want to reduce the downforce, the more we move these flaps down. We can also choose to move them individually around corners for some effect. It doesn't have a big effect, but some small effect differences. And then if we move along the car, I mean, we have also the active chassis that lowers and changes the rake of the car. We can lower the car and change the angle to change the functionality of the front flaps and the rear wing and all the other aerodynamic elements. If we get the car lower, the front diffuser and the side skirts and the Venturi have more ground effect. But we can also change the pressure point under the car depending on the rake of it. The other big visible active element is the rear wing, which is top mounted in order to have a smooth undersurface of the wing, which is the part that creates the most downforce effect. It's basically an upside down aeroplane wing. And you've seen on many modern Le Mans type of cars, they have pylons in front of the wing and they go down on top of the wing to avoid having a mount underneath the wing. We have taken that a step further, so our pylons are not standing up vertically in front, they're coming horizontally from the front of the car, and thereby creating less turbulence again underneath the wing. And even more so, we have the world's first top-mounted active wing as far as we are aware. So during braking, the wing drops down and creates an aero braking effect in combination with not fully stalling the wing, so we get massive amounts of downforce on the rear wheels while braking. And then we have many setting possibilities in between these two extremes. So basically the rake of the car, the height of the car, the individual front flaps with the top-mounted active rear wing. Those are the, let's say, Aero active elements on the car. So we've had the dream for many years actually to make a car that has a 1-to-1 weight kilo to horsepower ratio. And we built a GT1 race car many years ago, which actually without ballast had under 1,000 kilos of weight. But as this also is a road car and our customers demanded all the road car amenities, it is impossible to have that low weight. And that has prohibited us to doing a proper 1-to-1 car. But in parallel to that, our horsepower possibilities with our engine platform have increased over the years. Turbo technology has been improving, piston technology and piston coating, and cylinder head gasket technology, and many things needed to improve horsepower has become possible over the years. So we've been steadily raising our already high output to even higher levels, and we have now put in the most extreme type of carbon fiber technology in the chassis and the body, more titanium solutions, removing unnecessary functions and so on to reduce the weight of the car to find this point where it's actually 1-to-1. And coincidentally, that point was also very close to the number 1,360 in curb weight. And that number is also 1 megawatt. So we aimed to get to that number from all different angles. So it's the world's first 1 megawatt powered production car, homologated production car. And I mean, when you say 1,360 horsepower, it sounds almost ludicrous amount, and it sounds like it should be undrivable. We know that's a wrong assumption, because we have been up to over 1,200 horsepower with our Aero R with less downforce and simpler tire technology, and we can actually put that power to the ground. And with the increase of downforce, the reduction in weight and the improved tire technology, 1,360 is actually drivable, especially with the turbo technology we now got. So we got this huge power range. But still, we felt it was kind of a cool thing to build the world's first 1 megawatt car, and also kind of sedates the power. The idea of the power, that it's like a moped, it's got something of 1 in power, not like 1,360. So we believe it to be the world's first mega car, being that it's the world's first 1 megawatt car. So all the numbers for the car so far are quite theoretical, because we haven't driven 1 meter with the car yet. We have tested some of the subsystems in our Aero R test car, some of the suspension, some of the engine tweaks, some of the chassis settings, so we know quite a lot. And then we have thousands of hours of simulation. But if we look at what we know with the Aero R, the difference between the two cars, and look at the simulations, so 0 to 300 should be possible in around 13.2 seconds. There is a possibility, even though it looks very difficult, that we could do 0 to 400 in just shy of 20 seconds. And that would be, of course, something very fascinating, just to not go over 20 seconds to 400, and really unheard of. So we will try to do that, even on, it's probably the number I'm least confident on, but we will give it a shot. So yeah, the cornering G with our Aero R, which is heavier, which did not have as much downforce, but similar chassis settings, similar spring settings. We managed with the new Michelin Cup tire, the Michelin Cup 2, that are specially developed for the 1-to-1. We managed to get 1.92 Gs in constant cornering force. So we're very confident we will go over 2 Gs in cornering with the 1-to-1. So basically, I guess those are the numbers I can throw out right now. So of course we heard that all the big brands in the industry were creating their next level super hypercar, hybrid cars, and we were not sure what they were coming out with. We were assuming they want to trump our car, the Pagani, the Bugatti in every aspect, simultaneously we started developing the 1-to-1 program, so we want to make sure we overshot what we already did by quite a margin, and maybe we brought it a little bit higher than we needed to, we will see. But I think it will compare quite favorably to these new hybrid hypercars. But when it comes to us competing with the big boys, I think that's what we've always been doing, so that's nothing new. It's really a David against Goliath kind of scenario that we're pretty used to and are fine with and enjoy at the same time, I would say. I mean, we've always been very focused on reducing weight and not adding weight to the car, even though we add functionalities. And with the one-to-one program, that's really taken to the extreme, as we put in so many new systems of hydraulic and electronic nature to get all these active chassis possibilities and shock absorbers and 3G communication and whatever it might be. So we're actually adding around 30 kilos of componentry, and at the same time in total we're shedding around 80 kilos of weight. So that was really a huge challenge. So we've gone through every nut and bolt, every layer of carbon fiber in the chassis, upgrading to the absolute latest carbon fiber technology. Even under the skin, like inner skins for the front and rear bonnet are hollowed out and cut out and re-ribbed, and just things like door handles and pedal boxes, it's just slimmed down and thinned out everywhere. It's so many thousands of details that's not visible to the eye, but it's visible to the scale when you put the car on the scales. And of course, the Agera R was really a tremendous machine as a starting point, but adding this amount of power and reducing that amount of weight and downforce with the new tire technology and active chassis, it's going to be something very exciting to drive, I'm sure. So we have developed a 3G connectivity to the car, which is connected also to our GPS system in the car. So first of all, we can diagnose the cars on the fly, wherever they are in the world, as long as they have 3G connectivity or Wi-Fi connectivity. And we can upgrade programs to gearboxes and engines the same way. But that also gives us another possibility, because when a car is driving around, for example, the Nürburgring track, the GPS knows where it is, and if we have been there before and done a setup of our test car or another customer car, that car there will get the information that we have a program for that track that can pop up on the infotainment screen. So if we press this dynamic mode button on the screen, it will check the geolocation, and if it notices the car is at a track where we have been and done a setup, the name of the track will pop up on the screen, and the car will have a preset installation with geolocations around the track. So for certain tricky corners or passages or jumps, the car will reset its shock absorber, rebound and compression ratios, the ride height individual on each corner, and the aerodynamics to tackle that obstacle the best way. So it's basically geotagged the track and resets the car along the way. And I've never heard of this before in a road car. I think it's quite unique, and it's something we will keep on giving customer choice of tracks. As soon as we go to a new track, we'll set it up. We put that up in the cloud so they can download it. And also the customers of the one-to-one program, they can come to us and say, well, I'm going to this track, please join us and set up the car. And then that setup will be available to the other customers. So it's kind of a nice interactive tool that will develop over time and give more and more choices to the customers to have fun with their cars in an optimal way. So we're expecting to start driving with the one-to-one at the Nürburgring sometime mid-summer 2014. And before that, we will take our Agera R test car with some of the systems from the one-to-one and start feeling our way around the track. And of course, we expect the car to be immensely fast around Nürburgring, but it's a very challenging track, a very scary track, and especially at the potential lap times and speed this car is capable of, it's really pushing every limit in all directions. So we have to be very careful in what we're doing, but of course, given the competence of this car, it would be a shame not to show everyone what it can do, to us, to the owners, and to everyone else. We're all curious, I guess. So what we expect the customers to feel when they enter the car is, first of all, a great adrenaline rush, just walking up to the car, knowing what kind of a beast, a tamed beast this is. But when you get in and start, you get this really visceral experience, and it's kind of, you feel the car adapting to you and the environment and the place you're at, just to give you the utmost fantastic driving experience possible. It's really the idea to almost get sensory overload and gelling as becoming one with the car. That's what we're aiming for.